Good day to you, students. How are you doing? Today we'll be dealing with chapter 19.2, electrical circuits. Dealing with electronic circuits and electrical safety. Let's start the class. Electronic circuits. Electronic circuits make use of a number of other components to control the way that current flows in a circuit. There are two types of electronic circuits. We have the digital circuits and the analog type of what? Circuits. Digital circuits are circuits which give an output voltage that can be either high or low. That is from 6 volts to 0 volts. The output of the circuit is either on or off. Digital electronic systems are useful in transferring information. In an analog system, voltages can have any value, positive or negative. If you look at your phone, or if you look at your television, if you look at a personal computer, that is a laptop, and you open them up, you always meet an electronic circuit inside that is embedded, more or less like a microchip. This is what the systems work on. Now, let's deal with logic gates. Logic gates are digital electronic components, which are simple building blocks used to design electronic circuits. Each logic gate has a specific function and can be combined together to produce complex effects. The logic gate is a device that receives one or more electrical input signals. They produce signals which are voltages. High voltage is 1, which is on. Low voltage is 0, which is off. The logic gate has 3 major examples: AND, OR, or NOT gates. As you can see here, we have the AND gate at the top. At the middle, we have the OR gate, and below is the what? The NOT gate. Now, still dealing with logic gate, an AND gate function like this. Its output is on if both input 1 and input 2 are on. That means if those two sides on the left are on, then the output, which is on the right, will be what? On. For an OR gate, it functions like this. Its output is on if either input 1 or input 2 or both is on. This is what we are saying. From the previous slide, if you look at the OR gate, the one at the center, if the two lines on the what? Left hand side, if they are what? On, the output will be on, just like AND. But if either of the two on the left hand side is on, probably the one on top or the one below is what? On, the output will still be what? On. For a NOT gate, it functions like this. Its output is on if its input is not on. That means the input needs to be put to what? Off. Then the output will be what? On. If you put the input in what? On, the output will be what? Off. Now, their combinations and how they work can be described with the use of a what? A truth table. That means for logic gate that bears AND gate, OR gate, or NOT gate, you can describe them using the truth table. Now, let's see this question. The truth table shows the possible combinations of inputs and the output that results from each combinations of logic gate. That is what? True. So we check. That is correct. Now, look at this truth table for AND gate. If the input is 0, that is off, and the input 1 rather is 0, input 2 is 0, that is off, that means the output, which is known as input 3, will be what? Off. If input 1 is what? on, and input 2 is what? Off. That means input 3, known as the output, will be what? That will be off. The same thing applicable in the third process. If input 1 is off and input 1 is on with 1, the input 3, that is the output, will be off. If input 1 now is on and input 2 is on, that is 1, 1, the output will be what? 1. Now look at OR gate. Now, if either input is off, the result will be off. Now, if one of the input is on, just like we have 1, 0 or 0, 1, the output, which is input 3, will be what? On. Then, if you have both inputs, that is on, 1, 1, the output will be what? On. That's 1. For NOT gate, if the input is 0, the output will be 1. And if the input is 1, the output will be what? 0. So, let's continue also with truth table. The NOT gate, in which whether you have input or output, has only one input, which can be on and off, being the simplest table. The AND gate and OR gate both have two what? Inputs. Either you do on together or off together, or you repeat on and off at the same time. We also have other types of logic gates. We have NAND, we have NOR, we have XOR, we have XNOR. So, combining logic gates. How do we combine logic gates? Computer chips are made from millions of logic gates. They combine together to produce outputs that depend on many different inputs. The truth table is worked out by realizing that the output of the AND gate is the input of the what? Of the NOT gate. When the AND gate output is 1, the NOT gate turns this into what? That's 0. That is the what? Output. The order in which gates are connected together is very important. Example to show how 3 OR gates connected together or are connected together is described in this what? Diagram. Okay, other examples of logic gates are the NAND gate and the NOR gate. Let's deal with electrical safety. Mains electricity is hazardous because of the large voltage involved. A 5 ampere cable is relatively thin. It can be used for lightning circuit as it does not require much power. The metal case of an electrical appliance is half by connecting it to the half wire to reduce the chance of fatal electric shock. If excessive current flows in wires, they can heat up and insulation may melt emitting poisonous fumes or even catch fire. Avoid using electrical equipment that draws too much current. Due to this, a fuse is used. So this is a typical example of a fuse. You always get a fuse, but at the back of this type, you always get it at the back of a typical fuse that is built. It has different colors. It comes in white, it comes in orange color that is connected before you plug your main appliances into them. Now, let's deal with this question. Why is a circuit breaker or a fuse used in a mains electric circuit? A. It allows spare current to be returned to the mains. No, that's wrong. It saves energy by reducing the current. No, that's also wrong. It improves the insulation of the wiring. No. Now, the last one, but not the least, it protects the mains wiring from current overload. That is what? True. That is correct. Let's click it. Check. That is it. Now, we are still dealing with electrical safety. Fuses are materials included in circuit to stop excessive current from flowing. A fuse contains a thin section of wire as we have seen before, designed to melt and break if the current gets above a certain value. The thicker the wire of a fuse, the higher the current that is needed to make it to what? To blow, that is to break. Circuit breakers have two types used in electrical safety. We have trip switch and residential current device. A residential current device protects the user rather than an appliance or cable. Let's deal with these questions. A fuse represents a weak link in electricity supply chain. That is what? True, because that is what is needed to keep the current in check in order not to go beyond its threshold value. Circuit breakers work with the use of electromagnet. Yeah, that's correct. Let's move on. How is electricity transmitted over large distances, and why is it transmitted in this way? At high voltage for safety? No. At low voltage for safety? No. At low voltage to reduce energy loss? No. At high voltage to reduce energy loss? That is correct. That is true. So pick it. That's correct. Now, which statement is correct? An electric circuit will only work if it includes a fuse. That is wrong. That's a no. A fuse should be connected to the neutral wire in a plug. That is a no. An out wire is needed to prevent the fuse blowing. That is also incorrect. A fuse is included in a circuit to prevent the current from becoming too high. Yes, that is correct. Now, let's choose the correct statement before we wrap it up for today. Digital circuits are circuits which give an output voltage that can be either high or low. That is correct. Now, to the second statement, no circuit can give an output voltage that can be either high or low. Digital circuits can do that. So that statement is false. Analog circuits are circuits which give an output voltage that can be either high or low. The statement is what? False. It only belongs to what? Digital circuits. So we pick that. That's correct. And do well to join our website www.edubbey.com for more of our interactive classes, notes, and video. Want you to subscribe, and also visit our channel on YouTube. Bye for now.